Hello everyone. In today's session, we are going to discuss about the Floyd-Warshall algorithm, which is also known as the shortest path problem between all pair of vertices. If you remember in the previous session, we talked about the Dijestra's algorithm, which gives the shortest path from source to destination. Now, in Floyd-Warshall algorithm, there's a one extension when we compare it with the Dijestra's algorithm. The Dijestra gives you the shortest path between source and destination only. But when talking about the Floyd-Warshall, it gives the shortest path between every pair of vertices. Okay, so now in this Floyd-Warshall algorithm or the shortest path algorithm, we'll try to find the shortest path between every pair of vertices by making the distance matrix. Okay, let us see how we can write that distance matrix and then how that distance matrix further reduced or extended to find the shortest path as well as the shortest distance between every pair of vertices. Okay, so there are certain steps that we must know that how a distance matrix can be written, and after that we'll see one example that how exactly it can be incorporated to find the solution. So first of all, we are supposed to write the initial distance matrix whose entries gives you the distance between vertex I and vertex j. And that distance matrix gives you the weight between I to j, whatever is there directly on I to jth entry. If there is no direct edge, we write the weight as 0. So when a distance matrix is written, its entries I to j distance represent. Okay. If there is an edge between I to j, we are talking about the directed edge. Then that weight is written on the and that particular entry of the matrix. If I equal to j, I equal to j means we are talking about the diagonal entry, then that entry comes out as 0. And if there is no directed edge, if the graph is directed, we are talking for directed edge. If the graph is undirected, direction is not matter. In that case, we can say if there is an edge between I and j, there is no edge between I and j. This is how we can read it. So if there is no edge between I to j, that entry comes out as infinite. We are talking the direct connection for this. Okay, once the distance matrix written initially, then we write the sequence of matrices. Sequence of matrices means what? If a graph is having, let it be n number of vertices, so initial distance matrix measure the direct distance, then we'll include some more vertices in this path. Let it be vertex number 1. Then we call it as the first distance matrix, where in place of direct weight from I to j, we are interested to check the weight from I to j, making let it be k as the intermediate vertex. That means moving from I to j not directly, but I to k and k to j, and whatever is minimum from I to j directly and I to k and k to j sum directly, that minimum entry will be replaced or put it in that matrix we called as a first distance matrix. Similarly, we'll find the second distance matrix, third, fourth, fifth, whatever the vertices we do have. So in short, I can say that we are including vertices as an intermediate vertex in this matrix. Once all the vertices of the graph considered as the intermediate vertex, the process will stop, and that final matrix gives you the shortest distance between every pair of vertices. You can see this is how we are going to update the shortest distance. So the distance between the vertex I to j will be the minimum distance either directly directly from I to j, either directly from I to j, or if we are making k as an intermediate vertex, so include k in your path and then we are supposed to check. Okay, so the distance is minimum between I to j directly from I to j, or if you are making k as an intermediate vertex, so the find the distance from I to k and k to j, then the sum. Whatever is the minimum out of these two, that will be the updated weight or updated distance in the first distance matrix. And this is what we are supposed to do for every vertex and supposed to make as a intermediate vertex. Okay, so this is how we are making, or these are some rules that we will make the distance matrix. Yes, comparative to Digesta, it is a lengthier method because in every for every vertex we are supposed to make an intermediate vertex. Okay, now, let us take an example to be more clear on it. So, this is a matrix which is given to us, and we are supposed to find the shortest distance between every pair of vertices. Okay, so now, as I already told you, that we'll start with the initial matrix that we call as the zeroth distance matrix, which is having all the four vertices, one, two, three, four. Since this graph is a directed graph, so we'll suppose to follow the direction. Okay. If the graph is not directed, we can move from anywhere to anywhere as per the edge exists. So initial distance matrix, there are three rules on diagonal: 0, I to j, that is 1 to 2, we are moving like this. Okay, so 1 to 2, if there is a direct edge, that weight comes in the matrix. If there is no direct edge, infinite comes in the matrix. So first of all, we'll put all the diagonals as 0 because the rule says that if I equal to j, that entry comes out as 0. Now let us write the weight from 1 to 2. Just see this graph. Is there any edge from 1 to 2? Yes, this is the edge. The weight is 8. So this comes out as 8. 1, 2, 3. You can see there is no direct edge 1, 2, 3. Yes, there is an edge from 3 to 1. But we are supposed to write 1, 2, 3. So no edge means this entry comes out as infinite. Then 1 to 4. Yes, there is an edge. The weight is 1. Then 2 to 1, the edge from 2 to 1. You can check, we are unable to move out from 2 and come to 1 because the direction restriction. So that entry comes out as infinite. 2 to 3, yes, there's an edge, it comes out as 1. 2 to 4, 2 to 4, so 2 and 4, no direct edge, so infinite. Then 3 to 1. Yes, this outside edge, 3 to 1 exists. So this weight is 4. 3 to 2. No edge is there, direct, infinite. 3 to 4. 3 to 4. Yes, nothing is there, so infinite. 4 to 1. No, nothing is there. 4 to 2. So this is 4, this is 2. Yes, this weight 2 exists. Then 4 to 3. Yes, this weight exists 9. This is called as the initial distance matrix, which is constructed on the basis of the laws or rules that we discussed. If direct edge is there, that weight should be written. If direct edge is not there, infinity should be written. If it is the same vertex to same vertex, that is a diagonal, it comes out as 0. Understood the first distance matrix. Now we'll write the first distance matrix. We call it as D1. D1 means what? Now, in every path, we are supposed to include one vertex as the intermediate vertex. Okay. Now try to pay more attention on it. We are supposed to write D1 as a distance matrix. Now, we'll take the weights from the initial distance matrix. Now, there's no need to take the weight every time from the original graph. We will refer D0 as the matrix from which we will write the weight. Okay, let us write it. Diagonal, yes, quite obvious. All the entries comes out as 0. Now, we are supposed to move out from 1 to 2, making 1 as an intermediate vertex. Over here, what it means, in every path, we are supposed to make 1 as a intermediate vertex. That is the important thing. Means from wherever to wherever you are moving, one vertex should be included in it. If you see the first row, yes, one is already included. So directly the weights comes out. From the previous matrix, I will write direct weight from the previous matrix from because the first row, this is the first row, and the first column already including the vertex number one in itself. So directly from the previous D0 matrix. Now let us try to find other entries. So this entry we do have 2, 3. Let me write it how exactly we find the distance matrix. So we are supposed to move from where to where? Matrix vertex 2, 2, 3. Okay, 2, 2, 3, the direct weight is given as 1. The reference matrix 1. Now we are supposed to include one vertex 1 on it. So this should be 2, comma 1 plus 1, comma 3. That means between this, insert the vertex number 1. How much is 2 to 3 directly from D0? It is given as 1. What is 2 to 1? 2 to 1 is infinite plus 1 to 3 is infinite. So this is 1, infinite plus infinite is infinite. What is the minimum out of these two? Yes, it is 1. So this is how we are supposed to insert the intermediate vertex. Okay, you can do it manually. If having confusion, do write like this. Insert that intermediate vertex in your pair and then write the distance from the previous matrix, not from the graph, previous matrix. So this comes out as 1. Now 2 to 4. How to write 2 to 4? Let me write it once again. So 2 to 4, insert 1 in it. So 2 to 1 plus 1 to 4. Whatever the minimum is there between these two will be written on this entry. So what is 2 to 4? Take this difference matrix. So this is your infinite. What is 2 to 1? 2 to 1 is also infinite. 1 to 4. 1 to 4. Yes, this is 1. So infinite plus infinite, the minimum of these two, yes, it comes out as infinite. Now we are on this entry, which is 3 to 2. So suppose to insert the vertex number 1 between 3 to 2. So 3 to 2, insert vertex 1 on it. So 3 comma 1 plus 1 comma 2. What is 3 to 2 in the D0? 3 to 2 is given as infinite. What is 3 to 1? 3 to 1 is given as 4 plus 1 to 2 is given as 8. So this gives us infinite comma 12. And what is the minimum of infinite comma 12? It is 12. So this entry comes out as 12. Earlier 3 to 2 is infinite in D0. Over here you can say 3 to 2 is 12 in this matrix. Now the next entry, we are having 3 to 4. So 3 to 4 in the same manner. So 3 to 4, insert 1 as a distance in intermediate vertex and let us see how much it comes out. So what is 3 to 4 given? This is given as infinite. What is 3 to 1? It is 4 and 1 to 4, it is 1. So minimum of 5 comma infinite, which is 5. So this entry comes out as 5. Now the last column, last row, sorry, 4 to 2. So we are supposed to write the distance 4 to 2, making 1 as an intermediate vertex, and this is how it will be looks like. What is 4 to 2? 4 to 2 is given as 2, 4 to 1 is given as infinite, and 1 to 2 is given as 8. So the minimum of 2 comma infinite is 2. So this entry comes out as it is 2 as the previous one. Now 4 to 3, in the same manner 4 to 3, make 1 as an intermediate vertex, so 4 to 1 and then 1 to 3. What is this 4 to 3 in the D0 matrix? It is 9, comma, what is 4 to 1? It is infinite plus 1 to 3 is infinite. So 9 comma infinite minimum is again 9. So this we called as the first distance matrix for this graph. This will be our first distance matrix for this graph. I hope you understand it. Now we'll make second vertex 2 as your intermediate vertex. So let us see how we will make D2 matrix where the vertex number 2 is considered as an intermediate vertex. Let me rub these things. Okay, so for D2, now as we did in D1, what is our thing? In every pair, we are inserting D1 match, vertex number 1. So in D2, what is our task? Our task is what? To include the vertex number 2 as intermediate vertex in every pair. That means every path must include the vertex number 2. And now our reference matrix will be what? The distance matrix D1. Okay, so let us write over here now D2, the vertex or the matrix D2. So the vertex name is 1, 2, 3, and 4. And on upper side, it is also 1, then 2, then 3, and 4. Now, as already told you, all diagonal comes out as 0 directly. Now, every path must include the vertex 2. So over here, 2 is the intermediate vertex. Okay. Now the second row and second column directly come from D1. Now our reference matrix is this matrix. Huh? So the second row, that is infinite, 0, 1, and infinite. And second column, which is 8, 0, 12, and 2, comes out as it is. Why it comes out as it is? Because in all these paths, vertex number 2 is already included. Vertex number 2 is already included. Now let us try to find the leftover entries. So 1, 2, 3. Now we are supposed to make 2 as an intermediate vertex. So insert the vertex number 2 between 1 and 3. How it will be written? Let us see. So 1, 2, 3. Insert 2 in this vertex. So 1 comma 2 and then 2 comma 3. The sum of these two. Take this reference from D1. So from D1, 1 comma 3 is given as infinite. What is 1 comma 2? It is given as 8 plus 2 comma 3 is given as 1. So the minimum between the infinite and 9 is comes out as 9. So this entry will be updated as 9 earlier, which is infinite. Now, moving 1 to 4, making intermediate as 2. So 1 to 4, how it should be written? 1 to 4, insert 2. So 1 comma 2 and then 2 comma 4. So 1 comma 2 is 8. 1 comma 2 is 8 plus 2 comma 4 is infinite. What is 1 comma 4? It is 1. So the minimum of these two is 1. And now try to understand the concept. Whatever is your intermediate vertex that need to be inserted between every path. Now this entry is 3 to 1. So let us make between 3 and 1. Insert the vertex number 2. So 3 to 2 plus 2 to 1. Inserted 2 between this. What is 3 to 1 in D1? 3 to 1 is given as 4. 3 to 2 is 12 and 2 to 1 is infinite. So the minimum of 4 comma infinite is 4. Now the last one, 3 to 4 in this row. So 3 to 4 making 2 as intermediate vertex. Making 2 as intermediate vertex will be 3 to 2 plus 2 to 4. What we are calculating? We are calculating 3 to 4 making 2 as intermediate vertex and it looks like this. So 3 to 4, how much is given as 3 to 4? It is given as 5. What is 3 to 2? It is given as 12. And what is 2 to 4? It is given as infinite. The minimum of these 5 and infinite is 5. So this entry comes out as 5. Now Moving to the last row, 4, 2, 1, making 2 as an intermediate vertex. So 4, 2, 1, 4, 2, 1, making 2 as intermediate vertex will be written as 4, comma 1 and 4, 2 plus 2, comma 1, the minimum of these entries. So I inserted 2 between these two. So what is 4 to 1? It is infinite. 4 to 2 is 4 to 2 is given as 2. This is 2. Then 2 to 1. 2 to 1 is infinite. 2 to 1 is given as infinite. So now we will 4 to 1. This entry will also comes out as infinite, the minimum of these two. So let us make it as infinite. The last entry of D2 is 4 to 3. So 4 to 3, and we are supposed to make 2 as an internal vertices. So 4 comma 2 plus 2 comma 3. What is 4 comma 3 in D1? It is 9. What is 4 comma 2? It is 2. What is 2 comma 3? It is 1. So the minimum between 9 comma 3, which comes out as 3. So this is our second distance matrix that we called as D2. In the same manner, we'll write the matrix D3 and D4. We'll write the matrix D3 and D4. In D3, we will make the vertex number 3 as the internal vertex number 3 as the internal vertex, and in D4, we will make the vertex number 4 as the internal vertex. Okay, let us try to draw D3 matrix. So first we'll write all the entries, all the vertices name, which is 1, 2, 3, 4. Let me write it. So now we are on the vertex D3. So in D3 it is 1, 2, 3, 4. And on that side the same thing, 1, 2, 3, 4. So what is the task? The task is what? Make 3 as a intermediate vertex in every path. On diagonal, obviously, they comes out as 0. Third row and third column already included 3. So write it as it is from D2. Okay, from D2. So this is 4. This is your 4. Let me write it from D2. So this is 4. We are writing the third entry. So this is 4. This is 12. And this is 5. And the third one over here, it is 9. It is 1. It is 0 and 3. So the third vertex is already included in the third row and third column. So we are supposed to write it directly. Now we'll try to find the leftover entries of this matrix. So 1, 2, this is 1, 2. And in 1, 2, we are supposed to include the vertex number 3. So 1, comma 3 plus 3, comma 2. Inserted 3 between these two. Now our reference matrix is D2. So what is the weight from 1 to 2? It is given as 8. Then 1 to 3 is given as 9 and 3 to 2 is given as 12. The minimum between these two, yes, it is 8. Now 1 to 4, 1 to 4, and we are supposed to include 3 as a internal vertex. So 1 to 4, that means 1 to 3, which is 9. Already maximum, then direct 1 to 4. So write it directly. Okay, now the second column, second row. So 2 to 1 is infinite. Let us find a 2 to 1, making 3 as intermediate vertex. So what is 2, 1? In your D2, 2, 1 is infinite. What is 2, 3? 2, 3 is 1 and 3, 1 is 4. The minimum between infinite and 5. So yes, it comes out as 5. In the same manner, 2 to 4, 2 to 4, we are supposed to make 2 to 4, making 3 as internal vertex. So 2 to 4, insert 3 on it. So 2 to 3 plus 3 to 4. Take the reference from your D2. So what is 2 to 4? 2 to 4 is given as infinite. What is 2 to 3? It is infinite. What is 3 to 4? It is 5. So minimum of infinite comma infinite. Yes, it do come infinite. Now 4 to 1. So we are supposed to find 4 to 1, making 3 as internal vertex. So 4 to 3 and 3 to 1. What is 4 to 1? In D2, it is infinite. 4 to 3 is 3 and 3 to 1 is 4. So the minimum between infinite and 4, 3, 7 is 7. So this entry comes out as 7. Now 4 to 2. Now we are supposed to find between 4 to 2, making 3 as internal vertex. So this is how it should be written. What is 4 to 2? It is given as 2. What is 4 to 3? It is given as 3. What is 3 to 2? Given as 12. So minimum of 2 comma 15 is comes out as 2. So this is our third distance matrix. Now, the final distance matrix, we are going to make the final distance matrix, which is D4. And D4 is what? It will make the fourth vertex as internal vertex. It will make the fourth vertex of this weighted graph as an internal vertex. Let us try to draw it and see the final matrix too. So now we are moving for D4, the final matrix. In D4, what is internal vertex? We are supposed to make intermediate vertex as vertex number 4. Okay, so over here, what is the vertex? 4, it is intermediate vertex. So as we did in the previous three matrices, all the diagonal, yes, they comes out as 0. Now the fourth row and fourth column is already having the fourth vertex in the path. So write it as it is from the previous reference matrix. That is now your reference matrix is D3. It's not like every time you're supposed to search in the graph. No, do not do that thing. Otherwise, we will get confused. This is 1, this is infinite, this is 5. So your D4 is having fourth row and fourth column where fourth vertex is already included. So directly taken from D3 matrix. Understood? Now let us find the entries 1, 2, 2. 1, 2, 2 making 4 as an internal vertex. So 1, 2, 2 making 4 as an internal vertex. So 1, 2, 4 plus 4, 2, 2. How much is the distance 1, 2, 2 in D3? Yes, you can see it is 8. What is 1 to 4? It is 1. What is 4 to 2? It is 2. So the minimum of 8 comma 2 plus 1 3 is 3. So this entry will be replaced by 3. This entry will be replaced by 3. Now 1 2 3. So 1 2 3 making 4 as a this internal vertex. So 1 4 plus 3 comma 4. What is 1 2 3? So 1 2 3 is given as 9. What is 1 to 4? It is given as 1. What is 3 to 4? It is given as 5. So the minimum between 9 comma 6 is 6. So this entry comes out as 6. Moving to the second row, 2 to 1. So the distance between 2 to 1 when fourth vertex is making as an internal vertex will be looks like this. So 2 to 1 is given as 5 in D3. 2 to 4 it is given as 1 and 4 to 1 is given as 7. So that's the shortest between 5 and 8. Obviously, it's 5. So this entry comes out as 5. Now moving 2 to 3, making 4 as an internal vertex. So 2 to 3, making 4 as an internal vertex will be 2 to 4 plus 4 comma 3. How much is the 2 to 3 distance? 2 to 3 is given as 1 comma 2 to 4 is infinite plus 4 to 3. 4 to 3 is 3. So the minimum between 1 and infinite 3 is 1. So 2 to 3 comes out as 1. Now, the last two entries, 3 to 1, let us try to write those also. So for 3 to 1, let me rub these few of the entries. So 3 to 1 making 4 as an internal vertex. How it will be written? So 3 to 1 and 3 to 4 plus 4 to 1. What is 3 to 1 in D3? It is given as 4. What is 3 to 4? 3 to 4 is 5 and 4 to 1 is 7. The minimum between 4 and 12 is 4. So this 3 to 1 comes out as 4. Finally, the last entry, 3 to 2. So how to write 3 to 2? Insert vertex number 4 between them and then it will looks like this. 3 to 2 is 12 in your D3. 3 to 4 is 5 and 4 to 2 is 2. The between 12 and 7, the minimum is 7. So that entry comes out as 7. So now the graph is having four vertices and we have make all of them as the internal vertices. So if a graph is having n vertices, we are supposed to make n plus 1 vertices. We are supposed to make n plus 1 matrices, not vertices. And then hence this final D4 matrix gives you the shortest distance between every pair of vertices. Where there is an infinite in this graph? Where there is an infinite in this graph, like you can see 2 to 4 is infinite. That means we never reach vertex 2 to 4. We never reach vertex 2 to 4 by any of the possible paths from the given graph. Understood? So this is how we can use this algorithm to find the shortest path between every pair of vertices. I hope you understand it. Now let us close this session